In this session, we are going to discuss about transactions, one of the most important one in SQL Server advanced concepts, and you can expect at least 3 to 4 questions from these transactions. I am highlighting it's at least, it's not at most. So what is a transaction? Why you need this? Let's have a discussion about this and different types of transactions available and all the stuff. Okay. So a transaction is nothing but a single unit of work. For example, if you have 10 insert statements and if you want to make it as one atomic unit, like either all or nothing. So let me take the pen. You have 10 statements, 1, 2, 3, 4, or any TSQL statement. It's not only to be insert, it can be update, it can be delete, and something like that. Okay. And if you bind all these things into one unit of work in the sense, either everything should be successful or everything should be a failure one, I mean revert back. So if, for example, this insert is working fine, inserted successfully, and this is an insert statement successfully inserted, and if this is failed, then what it will happen, what it will do is it will roll back. That means this insert will be gone, and in the same way this insert. So that is the advantage of a transaction. While inserting huge data or while inserting some records, some foreign key relationship records, you are very well aware of the foreign key relationships, right? A master record should have, there should not be any child record without having master record. So in those kind of cases, whenever you are inserting some very important data, then you have to go for transactions. The classic example for this one is a bank account. When you are transferring from account A to account B, okay, it will have two statements. One is deducting from account A and adding to account B. These are two statements. If you don't bind these two statements into one transaction, then what will happen? Let's assume this is a successful one and this is a failure one, and that's a mistake. That's the biggest mistake. The amount will be deducted from account A and will not be added to account B. That means some amount is missing, right? So if you make it as a transaction, this guy and this guy, it will be either completely successful or completely roll back. If this is successful and this is failure, then it will roll back the first one also. So that is the advantage of having transactions in SQL Server. So in short, it's a single unit of work or atomic unit of work. If you can bind couple of multiple SQL statements into one unit, which will make sure that either everything is success or nothing, either full or null, then we call it as a transaction. If a transaction is successful, then all the data modifications made using the statements that are present in that one will be committed. Committed means it will be applied. The updates can be seen, and in short I can say it as it will become a permanent part of the database. And if it is failure, that means if it encounters any error, then it must be rolled back. So that is, in other words, all the modifications that you have done in the earlier statements will be rolled back. So let me take the, so generally to demonstrate the same, I prefer to take one table. I'm creating one, create table. I can take an existing table, but let me take a fresh one so that I can insert, delete, and do modifications with the data. I'm taking employee ID, the routine table which we take, employee table, employee ID integer. Let me define it as primary key. And the second table, second column is employee name. I'll take it as varchar of 100. And the third one is department, varchar of 100. And fourth one is designation, which is again varchar of 100. I don't know whether any table exists with this name or not. It is not. So the table created successfully. Generally, let's see the syntax, how the syntax will be. It will be like this. Begin tran, that means begin transaction, or you can go for begin transaction. So this is the starting of the transaction. By seeing this keyword begin tran, the server, SQL server will come to know that from here the transaction will be started. And once it is successful, commit tran. So it should be commit transaction. That means it can be committed. Everything is fine. So you can commit the work or commit the changes, or you can go for rollback. So rollback transaction will come into picture when there is any error, and commit transaction will come into picture when it is successful one. So these are the main three keywords that we use while defining the transactions. In general, let's say it will be like this: some if condition. If let's say at the rate of error is not equal to 0, you know this is a global variable, and that means it has some error occurred. Some error occurred in the queries that are present in the transaction. Here we'll go for rollback transactions. Else you'll commit it, right? Here the transaction will be started and you don't know whether to commit it or roll back. So how to know that? Using some error config. First you have to find out the error. What is the error? If there is any error or not. If any error, then roll back it. That's it. Or else commit it. So this is the basic syntax of a transaction. Now let me show you a couple of examples. Okay. Begin transaction. I'm going for begin transaction. I'm inserting some data into the table which I created just now. Values. I'll say 1, Rupesh, the next one is designation PL, department is IT. And I'm copying the same guy again, and I'm taking it as to Lokesh. Let's say the remaining are fine. And here I'm specifying commit transaction. So if both are successful, then commit the transaction. This is what it means. I'm not checking for any error transactions. So I'm going for only commit transaction here. So if I execute this, you can see both are successful and hence it is committed. And you can see the data in the table also. If you execute this, you can see 2 records inserted into the table. Now let's see an example for rollback transaction, how the rollback will be happen. It's not the case only when the error occurred. If you specify rollback, it will roll back. That's it. So for example, I'm copying the same query here. Instead of committing the transaction, I'm just rolling it back. Okay. And I'm taking ID 3, ID 4. I'll specify the names as Vinay and this name as Prasad. So these two are valid SQL statements which will be executed successfully. I know that pretty sure. This will be executed successfully. And now, instead of committing the transaction, what I'm doing here is I'm rollbacking the transaction. I don't bother whether it is inserting properly or not. And let me roll back it. F5, 2 rows impacted. Let me see the data. If you see the data is not committed. Because I asked the server to roll back the transaction. Rollback means it will take you back to the starting point. Whatever the queries that are present in the middle. Let me show you here. This is the ending point, rollback, where I specified. And it will take you to the starting point, that is begin transaction. That means it will roll back to the starting point. So whatever the queries that are present in the middle will have some output, right? That output will be reverted. That will not be applied to the database changes. These changes will not be updated in the database. So that is the difference between commit transaction and rollback transactions. There are mainly 3 types of transactions available, and there is no by default, guys. Commit it's not commit transactions. It's all how you define it. You have to explicitly specify it, whether it is a commit transaction that is you are looking for, or rollback transaction. I just showed you an example here. So actually it will be like a if condition. If any error occurred, then rollback, else commit. We'll come to that core topic, but just try to understand what is the use of begin transaction, what is the use of commit transaction, and what is the use of rollback transaction at this point of time. In couple of minutes, we are going to discuss about a bigger and better example, in which we will discuss about how we will make use of the transactions. Now let's see few transaction types. Auto commit transaction is one, and explicit, implicit, and there. Okay, one second. Implicit, it is a CIT. There are a couple of other things like there are many other. That is not of high importance, and I can say these are all the first level of categorization of transactions in SQL Server. Let's discuss about all these three with examples now. What is auto commit transaction? If you do not mark the boundaries of a transaction explicitly, what is the boundaries? Boundaries is this one. This is the starting point, ending point, and this is the starting point. If you don't specify the boundaries of the transaction explicitly, then what will happen is by default SQL Server will take each and every individual statement, TSQL statement, as a transaction. Okay, that means if I don't specify this, for example, if I did not specify the starting point and ending point, let's assume, then what SQL Server will do is it will read each and every select statement or each and every T-SQL statement as a single transaction. That means this is one transaction and this is one transaction. That means you have two transactions here. If you specify it as one transaction, then it will treat the complete set as one transaction. If you don't specify that, then it will treat each and every T-SQL statement as single transaction, and we call it as auto commit transactions. So if SQL Server treats each and every query as a single transaction, that means what will happen? If this is successful, then it will be inserted. That means it is committing. If it is failure, then it will be rolled back. That means it is rolling back. So every SQL statement either commits or rollbacks, right? If you don't specify the transaction starting point and ending point explicitly, then each and every T-SQL statement we call it as auto commit transaction. And here every statement will be executed, and if it is successful, it will be committed, or else it will not be committed and it will be rolled back. This is called as auto commit transactions. Auto commit means automatically every statement will be committed if it is successful. So till now, if you observe from day one, we were discussing about SQL Server basics and advanced concepts, right? We never use the transaction. So SQL Server automatically, it was the default mode was auto commit transaction, and every statement we have written till now was treated as a separate transaction, which we call it as auto commit transaction. And you can override it. You can make an auto commit transaction as an implicit or explicit transaction just by specifying this. If you specify starting point and ending point, it will become automatic. It will become explicit transaction. If you remove that, then it will be auto commit transaction, and each and every query will treat itself as a transaction. So this is about auto commit transactions. Now let's see an example for auto commit transaction. Sometimes it treats that all the, generally what I told, if I have 3 insert statements, let's say this is one insert statement, this is one insert statement, and this is one insert statement. Like that, I have 3 insert statements. Few cases it will not insert any record. What will happen is it will revert everything. People treat that this is not auto commit transaction. So in other words, it looks like the database engine has rolled back everything instead of the failure query. If the third one is failed, then what should happen in an auto commit transaction? Only this guy should roll back. Why it roll backs the first one and the second one? People treats like that, but it doesn't happen. Let me show you an example. I'm writing 3 insert statements. I'll insert into employee. Okay, I'm taking values up to 4, 3 I have 2 I have entered, right? 3 comma when I comma PL comma let's say IT field. So this is one insert statement. I'm taking one more insert statement where ID is 4. It's a Prasad. And I'm taking one more insert statement. Observe it very carefully. Here, instead of value, I'm writing a different spelling. A spelling mistake. Okay. If you observe this, the first statement is correct. This will insert the data. Second statement is correct. This will insert the data. But the third statement is wrong, and that means what you people will think is it should be rolled back, but the first and the second query should be executed successfully. But let's see what happens if I execute this. If I execute this, it is saying incorrect syntax near the value VALUSC, and if you go for a select statement, what will be there? Will I have the record 3 and 4 or not? Answer it quickly. Yes or no? Okay, fine. Most of the guys replied yes, and it is not correct. If I try to execute this, you can see only employee ID 1 and 2 is there, but 3 and 4 is not there. But as per the auto commit transactions, what should happen? That particular statement, each and every statement will be treated as a single transaction, and either it will be succeeded and committed or it will be failed and reverted back. Alright? But here it doesn't happen. The reason is this error is not thrown. The error what you are getting is not thrown at the time of execution, or I can say at the time of runtime. This is thrown at the time of compile time. So compiling, what is meant by compiling? First compilation will happen and then the execution will happen. While compiling, it will check for syntax errors. This is a syntax error. VALUSC is a syntax error. It's not a runtime error. So by the time it checks, it compiles and it finds out this error, nothing will be executed. It is the first step to check the syntax of the, just like build in SSIS projects. I hope you people still remember that. What build will do? Build will check for syntax errors. In the same way, first while compilation, it will check for the syntax errors and all the stuff. So this error will be found at the time of compilation. So that is why by the time it find this error, the spelling mistake or something, the wrong keyword, the first 2 queries will not be executed. That is why you won't see the data in the table, even though the first 2 syntax statements are correct. Now let me show you an example for the runtime error. I can say instead of employee, I can go for the syntax error. I'm going for value, the spelling with correct spelling, and I'm going for employee, the table name. This is not present. This guy is not present in our database. So until it executes, the server will not check whether this object is present or not. Why? Because some of the query before this, if I have 10 queries, one of the query may be creating this table, creating of employee table, right? It like something like this. Create table employee, something is here, and then I'm writing insert statement. If I execute this, and the compilation part cannot check with the existence of this table, cannot question the existence of table, because one of the query may be creating the table and I'm inserting the data once I created the table. You cannot write it as a compile time error, right? So these kind of errors will lead to runtime errors. At the time of runtime, the server will come to know that by the time this query executed, there is no object called employee. So let's execute all the three. You can see 2 rows inserted, but third one is invalid object name employee. The first 2 successful and committed, and the third one is not successful, and it will be rolled back. So this is called auto commit transactions. Now let's see about the explicit transactions. In explicit transactions, you don't have another go. You have to specify this begin tran and end tran. If you don't specify these, then it will not be treated as a transaction and it will throw a syntax error. So you have to specify begin tran and, sorry, it's not end tran. I'm going for if else conditions and case statements. It's a commit tran or rollback tran. And let's see how this guy works. I'm going for an example here. I'm taking these statements again. Okay, and I'm taking the values. I have values up to 3, right, or 4. I have up to 4. I'll go for 5. I'll go for 6. And if I go for 5 again, it has to throw error. Why? Because I've defined the first column employee ID as primary key, and I can go for employee table, right? But the primary key failure should occur here. Now here I'm checking if @ of error is not equal to 0, that means some error occurred. In that case, please roll back the transaction, else commit the transaction. So this is my intention. Either commit the transaction or roll back the transaction. Roll back the transaction if it is a failure. Okay. Now what I'm gonna do here is I'm gonna give a print statement. It's a failure, just to make the understanding easy for you to understand it easily. I'm giving the print statement failure, and in else I'm giving the print statement success. If you understand this, let me explain. First, let me finish the code, and then I will explain you. Okay. Now what I'm doing here is I'm beginning the transaction here, and I'm writing 3 insert statements, and there is an issue, and I'm checking the if else condition here. If @ of error is not equal to 0, that means there is some error. Then begin and print it is a failure, there is some problem, and roll back the transaction. That means revert back these 3 changes or 2 changes, right? By the time 2 changes will be done, right? Revert back those 2 changes and ending this begin statement here, and it will come out of it. Else part, when this if is not successful, that means there is no error, then begin, print it as success, and commit the transaction and end it there. So why I have given begin and end here? Why? Because I have more than one statement in else part. If I have more than one statement in else part, you have to make it in a batch, that is begin and end. In the same way, I have more than one statement in if part, so I have made it in begin and end. Now if I execute this, you can see this is executed successfully. This is second one is executed successfully, and violation of primary key constraint error has come, and it is going to the else part, and sorry, if part, and it is showing as failure. You can see the message is showing as failure, and it should have rolled back the transaction. Let me execute this and show this, and you can see it has rolled back. That means it hit this guy. So now if you see the flow, first it executed, and then this query successful, and then this, there comes the error. So it will check here for the error. Yes, this condition is valid, not equal to 0. So it is coming in to the begin and printed this guy, and by coming here it rolled back up to this guy. So that means it reverted the changes. Now what I'm gonna do here is I'm gonna make it as 7. So what should happen now? What will happen now? If I execute this, oops, 1 is successful, 2 is successful, 3 is successful, and it is coming to, at the error count is not equal to 0. Sorry, it is 0. That is why it is coming in and printing success, committing the transaction. Let's see whether it is committed, whether it committed the transaction or not. Yes, you can see it committed the transaction. So this is the advantage of having transactions, and this transaction type is called as explicit transaction, in which you will specify the begin point, I mean the starting point and ending point of the transaction. There is nothing called ending point. It can be either rollback transaction or commit transaction. It depends on the conditions in general. So whenever you are making use of transactions, then you will go for a condition check, like whether it is having any error or not. If any error, then gone. Revert back the changes. So one more way is 8, 9 and 8. We can go for try and catch. Catch this path. Okay. Try and catch is also used to catch the errors. One second, guys. Let me correct this. And now, earlier case, what we have used? We have used @error, right? Now, let's see how to use begin. Try. So in the transaction, what I have done is I have taken begin, try, and I have taken all these 3 statements. And if all these 3 are successful, then it will be committed. If any error comes in the middle, like let's say second query is not correct and it creates some error, then it will jump to catch. It will not commit. It will not come to the next line. Why? Because it is in try. Try means it will try and it will try to catch the errors. If there is an error, directly it will go to catch and it will come to this point and it will print failure and it will roll back the transaction. And let me make it as a print here, print success, in case it is successful. That means without errors. So what will happen if I execute it now? If I execute it, that the third insert statement is not correct, so it has to come to the failure part, and you can see it went to the catch part of the try statement, and the data is not inserted into the table. So let me execute the table and show the same. You can see the records are not inserted. Why? Because the try has found the error and it pushed the cursor, again it pushed the execution to the catch part instead of committing the transaction. Now let me change it to 10 and execute the same. You can see it is successful. It is inserted and it is successful. And you can see under messages, 1 row inserted, 1 row inserted, 1 row inserted, and it is success. And this select statement return 10 rows, and that is the result you are seeing. So this is how you can specify the begin transaction and end, use the begin transaction and end transaction to begin transaction and commit transaction or rollback transaction to bind all the queries into one atomic unit. So this is you just simply make a couple of statements, auto commit transaction statements into one explicit transaction just by using begin tran, commit tran, and rollback transactions. And this is how people go for a checks, like using @error and if statements and try catch blocks to catch the errors and roll back the transactions. It really helps. If you see the example I told you, bank account deduction and deposit into new account. If the deduction is done and deposit is not done, then the sufferer, the bank values, the amount will not get tallied. You will get some extra amount in the account. Or let's say you are adding into an account and then deducting from another account. First you added the data amount into one account, and while deducting the account, if it gives some error like connectivity lost or some issue, whatever may be the issue, then in that case again the amount will not be tallied. So these transactions will be very, very, very helpful in such kind of scenarios where you are dealing with money and where the financial transactions are going on. Now let's see about the implicit transactions. We discussed about auto commit transactions and explicit transactions. Now let's see a couple of examples on implicit transactions. Now let's see what is meant by implicit transactions. Implicit transactions, it takes the starting point automatically. You don't need to specify the begin tran keyword. It automatically takes the session from where the transaction will be begin. How to set that? For example, let's say I'm writing this statement. So the implicit transactions is the one where you don't need to specify the start point. That means, what is the start point? Begin tran. You don't need to specify this. How it will treat without specifying this transaction? Let me show you. There is a session which you can make use of, that is implicit underscore transactions. Using this, you can set, one second, you can you can enable the implicit transaction options. So once you enable this implicit transaction option, then you don't need to specify the begin tran keyword while defining the transactions. Let me show you an example. By default, this one will be set to off. It will be in off mode by default. How to enable this? So set implicit transactions on. If you execute this, the implicit transactions option will be enabled to true. Now, if I take this same, I'm taking the same one, or I'll take a different one. Let's say here, I'll take a simple one. Insert into employee values. I'll take 11, comma test, comma test, comma test. So this is one insert statement. This is another one. This is another one. I have 3 in this. This is the sec 12th. I'll name it as 11th. So just to get an error. Again, I'm checking the same condition. The condition is if @error is not equal to 0, then rollback transaction. Else commit. If you observe, I specified the rollback part, I specified the commit part, but I have not specified the begin transaction part. So what will happen is, if I execute this from the first statement after executing this set implicit transactions to on, then it will be treated as the first statement in the transaction. From here, the transaction will be started. It will be treated like that. And if you see, one successful, the third one is violation of primary key, and hence it has gone to the rollback transaction part, and the inserted recursor rollback. Now, what will be the next transaction? This is fine. After this implicit transaction, this is fine. This is taken as the starting point. Now, if I take any insert statement, or let me copy the same guy again. Okay, I've taken these 3 guys, and if I execute the similar if-else statement, so this is the ending point of the previous transaction, right? So the earlier transaction ending point is commit. So the next statement which is present in the query window, or which you are executing, will be taken as the starting point of the next transaction. So you don't need to specify the begin transaction. That's the only advantage of this implicit transactions. Once this is executed, this particular part, then the first statement will be treated as the starting point of the transaction, and it will go up to the last point, that is, say, the commit or rollback of the transactions. After that, if there is any select statement or any T-SQL statement, this will be treated as the starting point, and it will go until it finds either commit transaction or rollback transaction. So this is how the implicit transactions works. The advantage is nothing here. You can say that you don't need to write one statement. That's it. But the disadvantage, you can see this is pretty confusing here comparing to explicit transactions. So this is the difference between auto commit transactions, explicit transactions, and implicit transactions. The most widely used is auto commit transactions. It's not because people are using it by knowingly. They don't know and they're using it. But the next most used one is explicit transactions. Now, let's see the concept, how you can see how many transactions are open and what is the status of each transaction. So there are a couple of options to find out the same. One is the global variable tran count, which will give you the transaction count at this particular point of time. And another one is DBCC code check. You have a DBCC command using which you can check the open transactions, that is open tran. So DBCC open tran or @ tran count. Using these two you can check the open transactions. Let me demonstrate the same. At this point of time I don't think there is open transactions. Let me select and execute the same. If I select this cell, variable, global variable at tran count using the select statement, if it gives you 0, that means there are 0 open transactions, and if it gives you any number like 1, 2, 3, 4, 5, that means that many open number of transactions. And let's see the second one. The first one, tran count, has given you an integer value, either 0, 1, 2, 3, 4, and so on transactions present in the server connection. And the second one, this DBCC open tran, will give you the textual information, what is the transaction active and so on. If you see no active open transactions, that means there are no open active transactions and everything is closed. Now let's see a simple example. I'm taking a begin tran. I'm opening the transaction. I'm inserting couple of queries. Insert into employee values. I think I can go for 14. That is not present, I guess. Test, 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 and I'm going for one more statement with the same data, but ID is 15. I'm not committing or I'm not rolling back the transaction. I'm just opening the transaction. Let me execute this. You can see 2 records inserted successfully. Select star from table name. You can see 14 and 15 are inserted successfully. Now let me execute this @ open tran. You can see one transaction name is present. One value is present. That means one transaction I opened and yet to close that. You can see this is the transaction which I opened and still it is not closed. Now let me execute this DBCC open transaction, and this guy is giving transaction information for database AdventureWorks DW. And there is one transaction ID. The SP ID is 55. The name is user_transaction. That means user has defined this by explicitly specifying the begin transaction keyword, and the remaining information LSN and so on, start time, when it is started, SID and so on, user ID -1, and some information which you can make use of. So this is how you can make use of this @ tran count and variable and open tran DBCC check to know what are all the open transactions that are present in the particular database. So now I'm going for commit tran. Let me execute this. This is executed successfully, and if I go for select statement here, you can see it has become 0. That means I committed the transaction and there are no open transactions at this point of time. And now let me check DBCC open tran. You can see no active open transactions. So this is a beautiful option, the transactions, and knowing the transactions, how many are open and how many are closed. Based on this, you can rate the performance. If so many transactions are open and the data is not properly shared and so many deadlocks occur, then you are gone. So these guys will really help you in solving the performance and deadlocks that are caused by resource allocation and sharing. Now, including this, not only these tables, there are a couple of system tables. Let's say couple of tables like sys dot what is the table name? DM underscore tran underscore active underscore transactions. This is one table, system table. You can see sys dot is there. This guy will have all the active transactions that are present in the table and its status. You can make use of these transactions, and you can see this there is one implicit transaction also at the time 9:47 p.m. IST. I have defined this transaction and it was closed. And you can make use of these system tables to get the status of transactions. And there is a couple of other tables which are useful, or which will hold the data of the transaction status. That is sys dot I can say that is DM underscore tran underscore database transactions. Okay, and you can see a couple of other things also. DM underscore tran underscore, you can see current transaction. So all these tables will help you in getting the transactions information. DM underscore tran underscore session wise transactions. What are all the session wise transactions? So you can make use of all these tables to get the transaction that is active, and you have to analyze what columns are present in these tables and how you can make or prepare a query by joining all these 3 or 4 tables to get the data that is required, like what is the active transaction and how to find out the name and how to close that. I mean, if you get the details, then you can easily either commit or roll back the transactions, and if any resources are blocked, then you can release those resources. Roll back the transaction, it will roll back the date. Now I committed the transaction, right? After doing this DBCC check, what I've done, I have committed the transaction. Instead of commit transaction, if I roll back the transaction, what will happen is this question asked by one of our friends, and the answer is it will be rolled back. The data that committed will be rolled back. Okay, this is about the transactions. We discussed about implicit, explicit, and auto commit transactions with examples and the ways you can find out to see what are all the active transactions that are present in the session. And there are hell of topics to discuss in transactions, like nesting of transactions and save points in the transactions and distributed transactions. That's one way of transactions. And also we have a couple of other topics to be covered as part of these transactions, which will take one more session. So I'm gonna put a break here for this